Think we're recording. So thanks for being here, everyone. My name's Alan Rossman. I'll be the host and moderator of this panel discussion. The session today is a panel discussion among participants from the February and early March series of workshops who took some of those activities, or at least one of those activities, and implemented it in their own classroom with their own students. So we're going to be hearing from those folks about how it went, how their students responded, what their sense of how easy or difficult it was to implement one of the activities from the earlier workshops into their own classes. So let me remind you, I hope you were here for the earlier workshops, but in case not, or in case you want a reminder, these were the workshops that were presented in February and early March. Jen McNally presented an introduction to confidence intervals. Beth Chance, an introduction to one proportion inference. Jill Vanderstoep, an activity for comparing two means between two groups. Soma Roy, an introduction to correlation and regression. And then Beth did an activity introducing ideas of probability in the context of the Monty Hall problem. Today we have 9 panelists who will be talking about their experiences with implementing those activities. Angela is from Wisconsin Lutheran College. Ben is from Friends Seminary in New York State. Anna is from Oakton College in Illinois. Hallie from Walla Walla Community College in Washington State. Elise from Seattle University, also in Washington, of course. Laura is not here now. She may or may not be able to be here for the second half. She's teaching her own class right now. She's at Ridgeline High School in Utah. Amber is at College of the Florida Keys. Tiara is at the University of Arizona. And Elizabeth is at Pellissippi State Community College in Tennessee. The way we organized this panel discussion is that we posed 6 questions to the panelists and asked them to indicate which questions they were most interested in responding to. So these are the 6 questions you'll be hearing responses to. How much did you modify the activity to make it accessible for your students? What were the main characteristics of the context you used and how you implemented the lesson? What topics had students learned prior to the activity? How different was the activity from students' typical class experiences? How do you think students responded to the activity? And finally, what challenges did you encounter with implementing the activity? So the first panelist I'm going to call on to address that is Tiara at the University of Arizona. And I'll ask the panelists, when you answer your question, please tell us a little bit about your institution and the class that you tried this in and the composition of the student body. By that, I just mean, is it all psychology majors, all business majors, all students taking general education, or something along those lines to help us understand the environment you're teaching in? So let me stop sharing and ask Tiara to respond to the first of those questions.
Yeah, thank you, Alan. So I teach at the University of Arizona, which is a 4-year research university, but I am in the College of Applied Science and Technology, which is mainly an online college. And the students that I get are usually transfer students or students who have come back to school with some education behind them or a gap, but they've transferred in and they're taking an introductory kind of statistics class at the junior level. So for many of the students, they haven't had math in about 20 years, 10 to 20 sometimes. So a lot of weak backgrounds in math, and there's no prerequisite for a math class when taking my course. So that's kind of the there are a variety of majors: early childhood education majors, cybersecurity, organizational leadership, government and politics. So just a wide variety of students that take the course. Most are non-traditional students, but I have traditional students as well. So that hopefully gives you an idea of the student groups I work with. The activity that I implemented was the comparing two means using the multiple means applet on the African dung beetle data. So whether the African dung beetles use stars to navigate or not was the question that the students were being asked to basically answer. So I did need to modify what the materials we were given during the previous session in whenever that was, February, I guess it was, so a while back. I created a Google Doc out of it so that students could access it online easily and also interact with it together, depending on the number of students that participate. My online sessions, kind of going back to my courses, can have anywhere from 1 to 15 students in it at a time. It's an optional live session that they attend. Students from any semester, I've had one student, in fact, when I implemented this activity, I only had one student that attended that week. So depending on the module, more students attend versus others. So I needed to create the Google document to help make it accessible to students who are self-navigating through the activity. And just to make it more online accessible. I also changed some of the steps in the process, not too many, just to make them more in line with the way I start my course as far as like what is the research process, so that it sounded like the steps I take them through the research process. But most of the steps I kept intact. I just changed it, modified it a little to fit in the way I kind of cover what the scientific method is. I added some additional images. So if students were self-navigating through this activity, which most of them had to, they would see images of the various actions that were being taken in the simulation so that they could see that they were doing it right and follow along with that. I also had additional text boxes, which didn't have any new information from the materials we were guided with in February. But just kind of emphasize certain definitions like random assignment and standard deviation, just to kind of make them pop out of the page as they were reading through the activity. And then I did exclude the Jamboard activity. I did not have them do a Jamboard activity because for the online students, they often struggle because they're using a laptop or some of them even just a phone. So being able to switch back and forth from different slides to a Google Doc is somewhat difficult for them. So I didn't use the slides or the Jamboard, but I added some information that were in the slides that we were presented into the activity as kind of like these little breakout text boxes to say, look at this. This is kind of something cool you should look at. Like if you were there and you saw the demonstration with the hand shuffling experiment, I didn't use that hand shuffling slideshow, but I did incorporate an idea of what that was into my Google document for the students to say, if you did this by hand, this is what you would see. And then I went on with the simulation and had them try the simulation. And then I think the last thing I kind of switched up or did differently is I recorded a live session of me walking them through the activity so that they could watch that offline as well. Yeah.
Thanks very much. So I think the way we'll run this is I'll ask each panelist to answer the question that they volunteered to answer, and then we'll be sure to save a good bit of time for questions from the audience that can be directed at the panelists as a group or to individual panelists. So I mentioned that in case you have follow-up questions for Tiara, please make a note of them and hold on to them, and you'll have a chance to ask when we get through everyone. So next I'm going to call on Ben, who will address the second question on the list, which was what were the main characteristics of your context and how you implemented the lesson. And please give us a brief overview of your school and your students, Ben, before you answer the question.
Okay, it's great to see everyone here. I adopted the malaria in Yemen activity, and it was actually serendipitous, I think, that with if what was going on in the world in February, March, and still going on, unfortunately, talking about a public health issue in a place where there's also conflict made the whole exercise more relevant to my students. They knew where Yemen was, and so that I just want to highlight the value of the connection there. Okay, well, where did I teach it? I taught at Friends Seminary. It's a independent school right in downtown Manhattan. I was teaching high school students. I tried it in two different settings, though different for myself, but probably looking quite similar from your perspective. That is, in two classes, I taught it my advanced stats class. That's like AP Stats. Those of you who know the high school AP Stats curriculum, we dropped the AP program a couple of years ago, but I'm still following the old AP curriculum pretty closely. And so I used the exercise, the malaria in Yemen confidence interval exercise to introduce inference and confidence intervals. We had done a lot of practice of sampling with those students before in earlier units. We just previously done sampling distributions. So we'd done things like the Reese's simulation, the random rectangles, friends are probably know about, been around. And so they, and pulling out chips, the German tank problem, all these sort of samples. So they've done a lot of sampling. The other class I taught it to is a semester elective, and I teach two electives also that run next to the advanced stats. In the fall, it's an epi class where I teach statistics through epidemiology. And then spring, it's statistics for social justice, where we look at inequality and issues, particularly focusing on racism and structural racism, and how do we unpack that statistically. And so I used it to, we were in the middle of our study of the Great Migration, and students had already sampled from census returns historically for their city. Some did Chicago, New York, LA. And so they'd taken very large samples already. And we were just talking about uncertainty. And so I said, oh, how are you going to know the error on your the sampling error? And so we then did random rectangles and did Reese's activity simulations a little bit to get them understanding more what sampling's about. And then we did the malaria activity there. The point I want to highlight is what a pleasure it was to have Alan and Jen, experts, to read my revisions to the activity. It was such a treat to have academics look at what I'm doing at a high school level. So grateful for that. And so I had to rewrite the activity because my students did not know about p-values or significance level. And so I had to get them that sense of what would be surprising. And so, and it worked pretty well. The one thing I want to say is my high-flying students, the advanced stats students, they took it all in stride. Oh yeah, this is what I'm doing. And they very quickly calculated the confidence intervals via simulation, and we're ready to move on. They enjoyed it, but I think it served a good conceptual underpinning. We'd done some simulation earlier as an alternative earlier in the year, but my statistics of social justice class loved the activity. They loved the playfulness of coming up with a confidence interval. And I think that's one thing with simulation is bringing the sense of play in, and teaching a new idea that could be quite challenging via play was quite effective. And I'm going to continue to look at ways to do that. I think that's enough for now, but I'm happy to chat more about these topics.
Great. Thanks very much, Ben. Again, if you have follow-up questions for Ben, please make a note of them, and there will be a chance later to ask such questions. The third question on our list was, what topics had students learned prior to the activity? For this one, I'm going to call on Angela. And please do give us a brief introduction to your school and your students, Angela.
Hi, everyone. Yeah, I'm Angela Abling, and I teach at a small liberal arts college, so Wisconsin Lutheran College in Milwaukee. And it's the class that I taught it for was a gen ed class, so it's called Elementary Stats, and it fulfills a quantitative requirement for students. And so if students are doing calculus, they'll just do calculus and move on. If students aren't prepared for calculus, this is the class that they would take to fulfill, or one of a few classes they could take to fulfill that. So students tend to be freshmen and sophomores, but it could be anywhere from freshmen to seniors, and it's a wide variety of majors. So you get education majors, business majors, art majors, just a wide variety of students. And not many of them are science people, because if they're science people, they're probably going the calc route. So most of them are not really interested in the topic. So it's generally speaking, this class is a hard to get buy-in on. But the activity that I used was the malaria in Yemen activity, so the confidence intervals for the population proportion. And so in thinking about the questions I have, what had I covered before the activity and what knowledge did the activity assume? I only implemented it just this past week. So it's later in the semester that I got to it, because this course, the book that we currently use, is sort of a traditional stats textbook where first you do some data visualization, you talk about data exploration, you pause and do some probability stuff, which I try to minimize, but still cover it a little bit. And then finally we had gotten to, and our textbook does confidence intervals first and then does hypothesis testing. So I thought I was going to be implementing this activity earlier until I realized, oh wait, no, my students don't know hypothesis tests, so this activity won't make sense until I've covered that. So I ended up doing both the chapter on confidence intervals and on hypothesis testing before then implementing this activity. So those, like what I had covered up until then, we did hypothesis tests for a single mean and a single proportion, and we had done confidence intervals for those two as well, using sort of the standard equations, T and Z and so forth. And so what knowledge did the activity assume? I think the students needed to have an understanding of hypothesis testing, in that, like, what is a null hypothesis? What is an alternative hypothesis? How to set those up? Why do we have to choose between them? Like, what are they doing? And then also having some understanding of the alpha value, the significance level. So that way they could understand, well, if the p-value that the applet is giving us is such, compare it to that alpha value, even though we know it's sort of an artificial choice. It's just, they have to have something to go by. So that's that we did cover alpha values beforehand. I think students really need to have a good understanding of an alternative hypotheses. And the more background you can get on some of those things, practice ahead of time will really help. And actually what I found as I was implementing the activity is that an understanding of how the applet works was hard to do really quickly. So I did actually have them do a practice problem ahead of time on sort of the Harley example. The dog chews it, like, does Harley understand? And we practiced using the confidence interval, or the one proportion applet with that just briefly. But I don't think that was enough to get them to really, like, since these students, had much background, it wasn't quite enough for them most of them to understand the applet. The good students, the ones who seem to care more and are nodding along with me, kind of quickly got it. But I think the students that, sort of have a more difficult time with buy-in or maybe are having had less math background, found the applet difficult to navigate. So I think having some prep work in the applet would be helpful. Like, if I were to do it again, that's something I would do more, is if we want them to understand confidence intervals, they have to understand what they're doing in the applet first. So anyway, overall, still wonderful. I loved throwing this activity in a more traditional course. I do teach a different course, a biostats course, where we do simulation-based approaches. So it was fun to throw this into the more traditional course.
Thanks very much. Next, I'll be calling on Hallie. Let me remind you, the question that comes next is, how different was the activity from students' typical class experiences? So I will ask Hallie to tackle this question and remind you, please tell us a bit about your school and the students in the class you taught.
Yeah, so yes, my name is Hallie McCormick. I teach math and our one statistics class at Walla Walla Community College here in Walla Walla, Washington. It's in Eastern Washington. And we are a rural community college. In our stats class, it is a prereq for the nursing program on our campus. And so we have a fair number of pre-nursing students. And those can be students who are coming straight from high school and know they want to go into nursing, but we also get a good number of folks who are doing a career change and have realized that they want to go into nursing and are coming back later in life, 10, 20, 30 years after they have last seen math. And along with that, I would say that's kind of the plurality of our students. But a lot of people also take statistics, intro to stats as their just general math quantitative requirement. So we also have a lot of people just trying to get their math credits done. And in terms of ages, I guess we have some of those returning students, some students right out of high school, kind of more traditional aged, but we also have a kind of partner program with our local high schools. And so I also have a lot of students who are currently in high school in the class. So kind of a large range of familiarity with both mathematics and with the college environment. And I guess the kind of last thing I'll say about our institution is we, in the last, maybe some of my colleagues can tell me, 4 years, I would say, have implemented co-requisite classes for math. And so we do have cohorts in statistics who are taking this class with an algebra support to sort of beef up some of their math skills. And so when I implemented the activity that I did, which was the linear regression activity where we took student data, I took student data from my current classes, had them report their heights and their foot lengths. And we're exploring the linear correlation between those and in fact, coming up with a regression equation for that relationship. And so I implemented that with 2 different sections. One section was a standalone college level course, and the other one was the college level course, but those students had the co-requisite support class at the same time. And I would say, like, in my class, so coming back to the question of how different or similar is this from what they usually do, students, I would say in my classes had done a lot of self-guided class-long activities and several simulation-based, they had seen several simulation-based methods, but I think this was the first time that I put those 2 together. And so there were definitely a couple, I'm eating into the next 2 questions a little bit, but a couple challenges that arose from that. I think, like Angela was saying, just getting them familiar with the app environment. And I think the other thing that I would address next time is building sort of a culture of collaboration in the class more strongly, because I found that the section that was actually most successful with this was the co-requisite students. One, I think it's that kind of exploration and surprisingness that Ben was talking about, but also those students spend extra time together, and they were more used to working collaboratively and exploratorily together, and I think it was more successful in that environment than in the other environment where they were a little bit more reticent. So yeah, I would say, yeah, the structure in general was not foreign to them, but I think would have been more successful had I built more of a culture of collaboration prior.
Thanks very much. We appreciate your insights there.
Thanks.
The next question is, how do you think students responded to the activity? And I'm going to call on 2 different panelists to address this question. I'm going to start with Elizabeth, because Elizabeth also implemented the regression activity. And then after that, I will call on Anna to address this question. So Elizabeth, please go ahead.
So yes, my name is Elizabeth Weaver, and I teach at Pellissippi State Community College. It is the largest community college in Tennessee, and we have been doing co-requisite math since 2015. And so I did have actually all three sections that I'm teaching this semester are co-requisite sections, but the college level course is blended. So there are both college ready students and the ones who are in the learning support doing the stats class together. And I think that the reaction or how they responded to it was actually very different, kind of based on, it was actually, rather than being the co-rec versus or the learning support or not, was actually an age thing. One of my classes is in the evening, and I have slightly older students that are either returning for, wanting to change a job or just finish college, whereas my morning classes were a lot more of the traditional age and or dual enrollment. So the response that I got from the older group, because they had been working through their homework and they had been doing all the stuff all semester anyway, they actually kind of jumped in pretty quickly and really enjoyed the story of the linear regression, the crime scene activity. But I think that it really did kind of help with the more of a realistic use of linear regression, and it's not just 5 data points that all are very really closely on a line. And it was something that was a lot more real world, which I've tried to pull in throughout the semester anyway. But I think they enjoyed it. I think that I guess I'll see on the final how they actually responded to the learning part of it. But I think it was overall well received.
Thanks very much. Also on this question of how do you think students responded to the activity, I will ask Anna to address this question also. I think you might be muted, Anna.
Yeah, always happens. Okay, so I teach at Oakton College. We are a community college just outside of Chicago. My students are very diverse in terms of demographics and math knowledge as well. We have a lot of nursing majors, business majors, psych majors, biology majors, some computer science majors. My classes are capped at 24. I did this activity on Monday and I had attendance of 20. As far as the math background, some are just coming from developmental math, so very low level algebra. Some are in the algebra support. And every semester, 1 or 2 students is like in Calc 3 or DiffyQ. So I have to kind of, okay, how do I not bore you, but not overwhelm you? So that's sort of the challenge that every semester. But the good thing is stats are new to everyone. So there is that, and it's, and the class is intro stats. So I'm lucky to be in a computer room and I requested it. So every student has their own monitor. So that was very lucky. And so I will say that, so the first set of questions are what's the parameter, what's the statistic, what's the population? I did as a think, pair, share. And what was nice is they really appreciated the context behind it. And obviously, as was mentioned, oh, by the way, I did a confidence interval for proportion, malaria in Yemen. And so, yes, it was very worldly. And we had a really, really nice conversation about why do we need to estimate a confidence interval in this situation? Why wasn't the point estimate good enough, right? And this activity really sort of build on that and really showed them, yeah, but you can get another 355 and you'll get a different point estimate. So, so we had a very nice conversation about that. Then, since everyone had their own monitor, I kind of had everyone test their own proportion. So I said, you do this proportion. I kind of demos the app, and then everybody kind of did their proportion, and then I collected all the results on the board, and then we collectively decided what are plausible values. And before I go into that, yeah, the same challenges as everyone. It was getting used to the app. I've done simulations. I do the can Joy smell Parkinson's? We done coin tossing and spinners, so they understand the simulation and collecting more samples using hands-on. They understand what happens when you flip a coin, right? They understand what happens when you do a spinner, but it was hard for them to understand why the computer simulation is giving them what it's giving them. So as I was doing it, a thought occurred to me that the moment I do any kind of a tactile simulation, they toss coins, automatically go to a computer simulation and do the exact same thing. So maybe they'll make that connection that, yeah, computer's doing what you're doing, but a lot faster. So I can do 1,000 repetitions at the same time where you can't. So that's the one thing that I got out of it. Since my students are all levels, and technology is an issue for them to understand. So yeah, I had the most time explaining what is the app doing, right? And how to use the app. So we use StatCrunch, we use Pearson, and so Pearson owns StatCrunch. So we use StatCrunch. So it was hard for them to figure out how the app is doing the p-value. So I said, all right, open StatCrunch. So they went to StatCrunch, they got the p-value for whatever proportion they're testing, and then they're going to go into the Rossmann-Chance app and then see the simulation of that and see, where are these sample statistics coming and why are we rejecting. So that worked much better for them to understand and connect the two. So that was a nice connection. The one thing that I will say is that, so we do confidence intervals, we do a traditional book, we do way too much probability, but I have no say into how, I have to follow the syllabus. So we do way too much probability, spend way too much time on that, but it's a different story. So we do confidence intervals first. And then, so we do confidence intervals, one population, and then go into hypothesis test, one population. And so I just did this activity on Monday after they did hypothesis test and confidence intervals first, and I sort of tied the two together. And now we're gonna start 2 populations. So the one thing that every semester I notice is that students' confidence intervals is the hardest for them. For some reason, they get hypothesis tests more than confidence intervals. We have to get past to why the point estimate is not good enough. And then they really have this hard time understanding the interval, that anything between the two is plausible, right? That's very difficult for them. And it took me so long to figure out that a lot of my students were thinking that the confidence interval meant this value or this value, but nothing in between. It took me so long to figure out that that's how they were understanding that. And so doing this particular activity took care of that, right? Because they see the different values drop. And then I say, okay, did this proportion work? Why or why not? And then I put all of these proportions on the board and say, okay, could this be in the confidence interval? Could that be in the confidence interval? And that, I think, tied it more together, where they're thinking, oh, that's what she means when she says plausible. I also, it's a minor thing, but the word plausible, not everybody got that. So I changed that to possible. Is this possible? Could this be? So little things like that. But I think this really tied together of what the interval is, rather than it's, it's just this value or that value, because that's what they were thinking before. And then I asked them, so normally, since I'm in the computer room, normally I might give them a data set and I say, okay, use this data set and get the confidence interval and do a hypothesis test. So that's the kind of activities we mostly do. And then some simulations, like with coins and that kind of stuff. And so I did ask them, how did you feel about this afterwards? What did you think? And they did say that they really started understanding more what the confidence interval is. So that was so it would probably be better to do something like this first and then give them a data set and say, okay, now get that confidence interval and answer questions about that. So yeah, so this was great. I had a really great response, other than start using the simulation app earlier in the semester.
Thanks very much. The last question on the list we provided to the panelists is, what challenges did you encounter with implementing the activity? And the first panelist I'll call on to address this one is Amber. So please take it away, Amber.
Hi, thank you. Yeah, my name is Amber Severson, and I teach at the College of the Florida Keys at the main campus in Key West. The college is a small college. I was teaching my students in the Introduction to Probability Statistics class. Most of my students in the class are freshmen, sophomores, the general education students. I have some dual enrollment students. I have some veterans. I would consider them all young, most of them young. And this is one of my favorite groups of students. This day I taught, there was 10 in attendance. I think a couple were absent. But of all, I think 9 of the 10 students that I had that day, this lesson, I'd had in previous semesters. So there was a really good rapport with me and among each other. Let's see. The activity that I used was the Can Dogs Detect COVID activity. And so I'm going to call it a sticky spot. I don't know if it was really a challenge, but maybe a bump in the road. Some others have touched on it, just that using the app. When, when students, and I think we had done like a think, pair, share, we had come together, and then it was time for them to use the app. And so I had them in their pairs. I was like, okay, go get on the app and keep working. So then some were on their phones and some had their laptops. They were able to pull up the app, and I think, right, that the activity wants them to simulate using spinners. And that doesn't come up automatically if you click on, click the link to the app, right? The coin toss is what's just the default. So and then you can select use spinners, but it doesn't turn over right away. So it was okay. We overcame it. I just had to visit with each pair to make sure that they were able to get to where they could use the spinners. And once they were there, then I saw them being successful in using, inputting the correct probabilities and then simulating from there. But that to me, that was maybe a hiccup. It was not a make or break challenge or anything like that.
Great, thanks very much. So we have 2 more panelists that I've not called on yet, so I will call on them next. I think I'll just ask them to address any question they care to, since we've covered all 6 of the questions now. So next up, let me call on Elise. Please tell us the usual about your school and your students and which activity you implemented, and then whatever you want to tell us about how it went.
My name's Elise. I teach at Seattle University in a psychology department. It's a small liberal arts college, and the students prior to my class have had a 2-quarter stats and research methods class. They could have had it a year ago or not. They did a project. Math is touched on, but not a strong component, and we never do proportions in psychology. It's so just that was a challenge, I think, and so that's what we did. I had them work. Everyone has computers and work in groups on discussion and answer the questions on a discussion board so that we could then talk about it prior. Some of the students had this the stats a year ago. Some may have had it last quarter. So the idea, some of the main concepts may not have been in their head, like what a binomial is, how to think about probabilities and things like that. I did the dog first, but then I did a repeat with the baby, and that which is a binary, and they like that better. And I asked them on homework, what did you think about the first exercise? Half of them liked it, thought it was okay, don't know why we don't study proportions, and then the other half had no idea. And I'll ask again about the time too. But so it was good. And then we used applets again. And so I think, like other people have said, I would probably do a lot more lead in for the applets and maybe have questions about here, what's this thing mean on the applet? What's this thing? Just like the pre-work, because it was a leap, I guess.
Thanks very much. So now let me call on Laura Peterson. Laura was not here at the beginning because she was in class, I think. So Laura, if you tell us a bit about your school, your students, which activity you implemented, and anything you want to tell us about how it went.
All right, thank you. Yeah, my students just got my class just settled, but I'm Laura Peterson and I teach in Utah. I am actually a high school teacher, but I concurrent enrollment teach our Stats 1040, so it's a dual enrollment. So our 1040 is an introductory stats class. And so I use the Monty Hall problem. And I had already used, I usually use this simulation often, but I just make it part of my lecture. And so as we were starting into our unit on probability and what does probability mean, I implemented Beth's Monty Hall lab almost verbatim, just like she had used it. And it went really, really well. Although it was something different than what I normally did, my students, I have 30 students, and we introduced it and we kind of showed them how the lab worked and how to click around in it and how to download the questions that they were going to answer and things. And once I figured out how to share the worksheet so that they could actually make a copy, everything was perfect. But I got 28 out of 30 assignments back from them, which is way better than I get on most of my other, I implemented it through my LMS, so my Canvas page, and they engaged in it. They answered the questions. They, got to see the simulation and how switching or staying worked with the Monty Hall problem. I would definitely use it again and probably implement it the exact same way, but maybe use it earlier in the semester. The nice thing was it wasn't using the app that a lot of you guys were talking about. So there wasn't really a learning curve to it. It was very straightforward. And as Beth was demonstrating it, a couple months ago, she was definitely using it like day 2 or 3 with her students. My students were halfway through the semester or term by the time we used it. But it was a really good, activity, and I would definitely use it again.
Thanks very much. I want to thank all the panelists, first of all, for implementing one or more of these activities with their students, but secondly, for being willing to come here today and share their experiences with us. So we do have 13 minutes until the top of the hour for questions from the floor. So I don't know if floor is the right word when you're on Zoom, but if anyone has a question, you can raise your hand using the Zoom thingy, or you can type it in chat, or you can just unmute and go. The first hand I see is Ben's. Go ahead, Ben.
Yeah, I wanted to just highlight two points. I liked what Anna said about that for the confidence interval activity, it wasn't just about the endpoints. That doing the activity, working with other values within the interval, gave full weight to all the values in the interval. I thought that was a particularly valuable aspect of teaching confidence intervals. The second thing is more of an open question, and I wonder in the collegiate setting if this is what you do. I think it's really important to before I get doing inference is do the actually pulling chips out of a bag, actually pulling sampling with my hands. And I'm wondering, because for me, I think it makes then the simulation clear. And I appreciate the way the Rossmann chance simulation connects with the reality of pulling chips from bags and spinners and so on. Because I think doing something with your hands is the intermediate step. I just want to ask that as a query, or it may be just my philosophy there I'm imposing.
Thank you. Anyone want to respond, either panelists or anyone else, about using tactile sibling?
I was just gonna say that when they do it with their hands, when they flip their own coin or flip, or spin their own spinner, they believe it. There's a sort of like, what's this computer doing? I don't understand. But when they do it, they believe it. And so if you can do that first and then go to the app and say, okay, the computer's just doing exactly what you're doing, but a lot faster.
I
Other
would say that the
reactions?
time spent doing the physical simulation does pay off when you're looking at what does the output mean, because you can constantly go back and unpack what does each one of these dots mean on the distribution. Oh, that's a collection of X number of coin flips. Remember when we did that and we took our sticky notes and we made a distribution ourselves? It really does help to cement in the idea that this is about a random process that we're repeating over and over again to see if our results are extreme.
The reactions to Ben's question before I ask for a new question? Thanks for kicking off the Q&A here. Gail, go ahead.
Okay, as long as you're on the hands-on stuff. So my colleague and I, who is not a statistician, but we have come up with 5 principles that are, I will try to share them in the chat too, but we found them very useful for our work. And the first one is hands-on. Any way that you can get the kids to get kind of dirty with the data or hands-on with the ideas. The second one is definitions at the end. So you don't start telling them what the thing is. You wait until they've messed around with it and have some understanding of what it's about before you put a title or a name to the idea or the process. The third one is scaffolded steps to understanding, so that you move from that handheld to maybe sometimes we do kind of they write a little activity to actually create the simulation before they move to the app. And so there's kind of a staggered process of they move from I did something hands-on, now I'm gonna, just do a coin toss thing without, or write something, generate 6 numbers instead of actually tossing the coins and seeing them, but write a little kind of step thing where they just randomly generate 6 numbers and people record. But it's kind of a next step where they can do it faster than actually tossing the dice by themselves or whatever the model is. The fourth one is to actually look at some kind of a visualization. And that's mostly what we do in stats, is we look at all these simulated distributions and try to talk about that simulated distribution. And one of the really big deals is to collect everybody's output. Yeah, I heard you guys talking about that, but collecting everybody's output so that you can see the variability and understand why you need an interval estimates rather than point estimates. And then finally, and this is a really critical part and one we often overlook, they have to be able to communicate both verbally and in writing what they found out and what the end result is in terms of the question that they were investigating to begin with. So I don't know if that will help, but we found it really useful in structuring the way we think about activities.
Very good. Thanks very much. About another question, either it's specific to a panelist or general or anything you want to ask or comment on.
I have a comment about the hands-on, because my students can't do hands-on in the online setting. So I've struggled with that, having taught in an environment where I can do hands-on activity and then moving into this online environment. I have found that apps are really helpful because they allow you to show one shuffle, and then the second shuffle, and then the third shuffle. So I think that gives the online students, at least the one student who showed for this particular activity this term, she has been struggling this term with the material, and she understood that really, really well just by going one shuffle to a second shuffle to a third, and then doing 997 more to see the entire, simulation played out. And it seemed to work well in terms of that hands-on application. And the Google Sheet requires them to be more engaged with that, I think. So that's just my experience with the hands-on but hands-off aspect of that.
Thanks. Let me point out a couple things in the chat. Gail, if you have a link or any reference you can point to about those 5 principles, people would appreciate that. Laura, you put in a link especially for Tierra. Do you want to mention what that is?
Yeah, just Tierra, maybe because I've taught this online, and then like I think students, like as you said, like doing just one case, right? So like seeing one spin and understanding, oh, that one spin represents, whatever it represents. And the applets are kind of like aggregate, right? And the visual is nice, but it's not as detailed. So this is just the tool I use where you can actually see the whole spinner, and you can put things in a bag if you want to, and it actually looks like the real. I've used it when I teach it online because it looks like the thing that you would have in class.
Thank you. Nathan asked in the chat, has anyone asked their online students to actually go flip coins themselves and submit the results through a Google form or something like that? Any online teachers with experience at that?
Hi, Alan. I had a question.
Okay, go ahead.
How can I ask a question for everybody that implement this activity? How can you handle the time constraint that happen with this kind of activity? When we want to implement this kind of activity, we had to cover a lot of material during the semester. And sometimes we feel if we go for one activity in the next class, we had to make a shortcut of the class. That happened to me sometime. I cannot do all my session implementing activity like this. How can you handle that? What is your experience?
Any of the panelists want to address? How did you find the time to implement this activity?
One of the things that Utah State does is with their introductory stats class, they also have a lab or recitation. So their introductory stats class on campus runs with probably 200 plus students. And then they go into smaller. And so although it's a 3-credit class, they meet probably for 4 hours or more during the week or whatever, with an hour of that at least in their recitation. And so they focus their recitation time on, some of these hands-on activities and those sorts of things to help the students make connections. So if you have that ability to have, small breakout groups or whatever, that definitely helps with the implementation.
Thank you. Other responses to the how in the world do you find time for such activities question?
Yeah,
me,
I do. Oh yeah, go ahead.
Oh, sorry, Tierra. I guess for me, part of it is like getting sacrificial about some of the other material that I think like some of this, establishing a really firm foundation with this to me is more important than, spending a week on addition and multiplication rules. And so like I, have rearrange some of my topics to de-emphasize some things and spend more time on this kind of more, I think, valuable foundational intuition. So it's not a great answer, but that's what I've done.
Thank you. Tierra, did you want to jump in also?
Yeah, I think being sacrificial is kind of key in some way, but for an online class, you can be that way. It's kind of like a flipped classroom because my live session is more activity oriented and engagement. Whereas I ask them, not that they always do that, but to watch pre-recorded lectures. So they're getting a lecture beforehand and then they're coming, hopefully, but not always, prepared for the activity that I do.
Thank you. There have been several comments in the chat in case you haven't been following, but if you are able to follow, Gail put a link to an article that she and a colleague wrote about the ideas she expressed. Some others have jumped in about online teaching and using breakout rooms to have students flip coins, for example, in an online class. 2 minutes till the top of the hour. We have time for a quick question if anyone has a quick one they want to ask. Why don't we stop there? Let me say before we stop that we'll do another panel discussion just like this next Friday with a different group of 8 participants who have implemented one or more of the activities in their class. It'll be 1 hour earlier than this week's was. So it'll be at 10 a.m. Pacific time, 1 p.m. Eastern time. And you'll get an email from me with a Zoom link next Tuesday or Wednesday or something like that. Thanks again to everyone for being here. Thanks especially to the panelists for implementing these activities and sharing their thoughts and insights with us. So thank you all. See you next Friday, I hope.
Thank you, Alan.
All right, folks.